Welcome guys to this second part of the example. In the first part we graphed the joint density function, which was this. Let me make it a little bit bigger. Of course, this triangle in the left part is the base of this pyramid. So now what we want to do is to compute the probability that less than 1/2 of the tank will be stocked. That's our variable x. And more than 1/4 of the tank will be sold. That's our variable y. So we want to compute this probability. X less than 1/2, and remember that the comma represents the intersection, and y being greater than 1/4. So that's the probability that we want to compute. So let's try to figure out how to establish these conditions in our triangle here. So we want x to be between 0 and 0.5. So all the points in this red triangle where x is less than 0.5 are all this. Let me do something like this. So this blue triangle are all the points where x is less than 0.5. But that's just the first condition. We need to include the second condition. So let us do it in green, the second condition. And the second condition was that y was greater than 0.25. So we have here 0.25. I will have to adjust this, but don't worry, give me just 1 second and I will do it. This is not the actual area, but I need to zoom out. So let's take this, move it all the way here. Let's take this, move it all the way here. So the green triangle represents the second condition in y. These are all the points where y is greater than 0.25, and the blue triangle represents all the points where x is less than 0.5. So since we want both conditions at the same time, of course the intersection is going to be just this small triangle. So let me undo everything. Well, not everything, but these points that I included, and let me draw just the area that we want. The area that we want is just from 0.25 to 0.5. Remember, x must be less than 0.5, and here and here. So this small triangle, this blue triangle, is going to be now the base of our sub-pyramid here. Here you can see that this triangle is already drawn in our 3D model. So let's get rid of the 2D view so we can work just with the 3D view. Let me make a little zoom. Okay, now. So now we're going to do the exact same thing that we did with the original base, with the big base. We're going to take point F and see where it's mapped by our density function, then point G, and then point H. So point F, the first coordinate of point F is 0.25. So let us define another point. Let's call it I, with coordinates 0.25, comma 0.25. And now remember that our function took or takes the first coordinate and multiply it times 3. So 0.25 times 3 is just 0.75. So that's going to be our point I. If we look it from this perspective, it should be exactly above point F. Now we do the same thing with point G and point H. Let's define another point with coordinates 0.5, 0.5, and now we take the first coordinate and multiply it times 3. That's going to be just 1.5. And again, this point must be exactly above one of our original points, which it is. We can see that it is. Now the same thing with point G. So let's define point K with coordinates 0.5, what is it? 25. K is 0.5, 0.25, and again we take 0.5 and multiply it times 3, and it will give us 1.5. And that's it. So where is it? Where is my point K? I don't have point K. Why? Sorry. There it is. So it should be exactly above, and it is. So let's change color for point K. Properties and blue. Alright then. So now we have the projected points of our triangle here in the base mapped into the surface of our big pyramid. Now again we only need to draw some lines, some polygons. So let's begin. So we have our first, we have the right wall, if you will. Now let's draw the left wall. That's it. Now we need to draw the top piece, this triangle JKI. And that's it. Hopefully you can see, let me make a little zoom. Hopefully you can see the sub pyramid or the sub figure inside our original pyramid. So now we want to compute the area enclosed in these blue walls. Let me draw the back wall. I haven't drawn the back wall. It's this, that's it. So now it's complete. So we need to compute the area inside these blue walls. So the way to do it, of course, is not with drawings, because here we are fortunate enough to be working with 2 random variables, but imagine if we're working with 3, 4 or more, then we would not be able to draw those things. So we need to use some calculus. So let's take this probability. Let me select this probability. Let me copy it. That's it. So this is the probability that we want to compute. So how are we going to do that? Well, remember that this, let me switch to my pen, that this is the integral, 2 integrals, because we have 2 variables, 3x. Now we can integrate first with respect to y and then to x. That means that the limits of integration are going to be from 1/4 to x for the y integral, and for the x integral we're going to have from 1/4 to 1/2. And these integrals are very easy. The first integral is just let's compute. Let me erase this. Let's compute first the first integral, of course, from 1/4 to x of 3x dy. This integral, of course, is going to be 3xy, and we're going to evaluate from 1/4 to x, and this is going to be just, let me write it over down here, 3x² minus 3/4 of x. So now we can plug this value instead of our first integral. So we will have something like this. The double integral 1/4, 1/2, 1/4 x 3x dy dx can be written as the integral from 1/4 to 1/2. You don't have to wait for me, guys, you can do it faster. I'm just trying to be extremely careful and extremely clear. Dx. And now we can compute this integral, which is just 3x³ over 3 minus 3/8 of x², and everything is going to be evaluated in the limits of x, right? So this is going to be x³ because these cancel each other, minus 3/8 of x², again with the limits 1/2 and 1/4. This is going to be, with a little bit of algebra, 1/2 cubed minus 3/8. Remember, guys, this is not a calculus class, so if you're having trouble with these integrals, you still have time to review them. 3/8 times 1/4 squared, and all this, let me copy it so we can change slides. All this is going to be 1/8 minus 332 minus 164 plus 128. If you do this computation, you will end up with 5/128, which this is roughly 4%. So we are done. This is the probability that less than 1/2 of the tank is going to be filled, will be stocked, and more than 1/4 of the tank will be sold. So the answer for this is roughly 4%. So it's a very low probability. So again, that's it, guys. Thank you. Hope that this example clears some of the questions, and see you in class, guys. Bye.